To say about the introduction to engineering graphics as well as what is the importance of engineering graphics in your engineering life. So coming to the importance of studying engineering graphics in engineering life, the first one is it is a language of engineers. So we call the engineering graphics or engineering drawing as a language of engineers mainly because the way the engineer is going to communicate the ideas is based on engineering drawing. So two main parts, one is it is a language of engineers and the communication of ideas will be done through the drawing. For example, if you take any blueprints of any building, so that person by explaining, we can't explain what exactly the building has to look. But if you have a blueprint of that, it easily explains what exactly your idea is there. Similarly, when you go for a circuit diagram of any of electronics, easily you can explain what exactly is there inside your electronic device with instead of explaining through a normal words. So coming on to this picture. So from this picture, you can see a small miscommunication can lead to a major failures in the construction field or whatever it may be a engineering field. So technical drawing allows the efficient communication among the engineers and can be kept as a record of the planning process. So coming on to the definition of engineering drawing, it is most commonly referred as engineering graphics and it is the manipulation of designs of variety of components, especially coming into the engineering field. And it primarily consists of a sketching of actual components. Example, it may be a machine or it may be an automobile or it may be a mobile, whatever it may be. So it is should be a exact dimension. The scale of dimension can be suitably adjusted based on the outfit of the drawing. If you take an automobile, it cannot be fitted into an A4 size or A0 size. That has to be reduced and then you have to be fitted into the required drawing sheet. So coming to syllabus, what exactly you are going to learn in this semester? The first module will be deals with the introduction to the computer aided sketching. So where normally you're going to study about how the manual drawing was there and how it evolved from manual drawing to a computer aided drawing. The second module deals with the orthographic projection. So orthographic projection, here we're going to study about what is orthographic projection and we're going to study the projection of points, projection of lines and projection of lamina. So the projection of points is only for the understanding sake, it not be asked for your examination. As well as module 1 is also only for the understanding and it won't be having any questions in the examination point of view. Coming to second module, so you're going to get projection of lines and projection lamina that will be asked for 25 marks. So you're going to have an option, either you can attend the projection of lines or projection of lamina. So coming on to module 3, where you're going to study about the projection of solids. So this is the major module in your syllabus which will carry 50% of your syllabus and that is the marks in the examination. That is, it has 45 marks from the examination. So one question will be asked from this module 3 and it carries 45 marks. Coming to module 4, so you're going to deal about the lateral surfaces of a solids. So you're going to go for a section of solids as well as developing the sections of a solids. So this carries 30 marks in examination and you have an option also for that. That is nothing but the module 5, that is isometric projection. So you're going to use only the iso scale for that diagrams. So here you're going to convert the two-dimensional images into a three-dimensional view. So here again carries 30 marks. So module 4 and module 5 are options. So either you can attend module 4 or module 5. So these are the 5 modules you're going to study. In that majorly you have to study about module 3. Module 2 you have an option either lines or lamina. When you go for third, again you have an option as module 4 or module 5. So there will be 3 questions asked from the syllabus. So one question carries 25 marks from the module 2, 45 marks from the module 3 and 30 marks from either module 4 or module 5. So coming on to types of projection in a daily life. The perspective projection is a 1-point projection will be there, a 2-point projection will be there, a 3-point, where the object will be enlarged as based on the difference between the screen and the observer. If this is the screen and this is the observer, as the observer varies and the object varies, the image will be varied off. Okay, that is the one perspective projection. When you go for orthographic projection, so if you take the object, it goes in a parallel way. And you're going to project, it has to go in a parallel way. So that is the orthographic projection. If you take the projection, this will be parallel to the plane. Or if you take the vertical, so it goes vertically downwards and it takes the parallel projection with respect to vertical plane. So in the orthographic projection, the size of the object remains the same as the actual size. It won't be reduced or it won't be increased. So you can easily identify the size of the object. Whereas perspective, the size of the object cannot be identified in a easy manner. The last one will be isometric projection, which is also type of orthogonal projection where you're going to get a three-dimensional view of an actual object, and the scale will be reduced to isoscale. So coming on to the overall graphical representation over there. So one is the parallel projection. So the parallel projection will have orthographic or oblique. So in orthographic, you're going to have multi-view. So multi will have a first angle and third angle, where you're going to get both front view, top view, as well as a profile view. Again, third angle. So in a different manner, the isometric will have a three-dimensional view. When you go for perspective, again, 1-point projection will be there, 2-point or 3-point projection will be there. Coming into the drawing methods. So the first one is the manual method. So where they're using the mini drafters, drawing table, drawing sheet, so and the drawing instruments. Coming into computer, so computer aided, they'll be using the softwares for drawing the projections. The softwares either may be from Solid Edge, SolidWorks, CATIA, ProE, AutoCAD. So whatever the software is available, that can be used for the drafting purpose. So what are the instruments used? The instruments are used like this. These are the instrument used: drawing board, set square, French curves, templates, mini drafters. So this is the mini drafter. The different kinds of pencil will be used. That is the T square and other instruments which will be used for the manual drafting. Coming to drawing sheet, the drawing sheet will be varied from A0 to A4. So it starts from 841 to 1189, and this is the drawing sheet. So this drawing sheet will have this is the overall drawing sheet. If you take this one, this is the overall, and this is the borderline in which you're going to draw the projections. And this is your title blocks, which contains the details about the drawing. And this part it can be used for representation which angle of projection you have done in your drawing. And there will be another box at the top. So this gives the information of revisions done to your drawing. And these are the different sizes of a drawing sheet. And these are different types of lines which will be used for the projection type. So when you go for that, there will be a continuous narrow lines and continuous narrow freehand lines will be there that use the splittage of the continuous limits, or you're going to have a cut section or a sections. Zigzag indicates the partial or interpret views. Continuous white line will be there, visible edges or visible outlines. Dashed line indicates the hidden lines or hidden outlines. And there will be long line and dot which indicates axis lines, other things and all. Okay, so these are the different lines you can use for the projection, and it shows the line conventions. So visible outlines and hidden outlines and axis line. Coming on to the lettering. So lettering has the different things which we want to follow in the manual drawing. That is the size of the letters and width of the letter, the thickness of the letters, everything comes in the picture. Coming to dimensioning. So dimensioning, there will be two methods of dimensioning. So coming to dimension is nothing but you're going to represent what is the actual size of the object, whether it may be length or diameter, width or thickness. Everything will be specified. That is called as a dimensioning. There are two types. One is aligned dimension and unidirectional dimension. If I take the aligned dimension, so you can see this is the dimension line and this is the dimension. So both are aligned. If you take here, it is inclined and the number is also inclined with the dimension line. Here also it is vertical. The dimension is also vertical. Whereas here the dimension is vertical, whereas the dimension specification remains in a horizontal position. Here it is horizontal. This again remains in horizontal. So unidirectional, irrespective of the dimensioning line, the value remains in a horizontal position. Whereas in aligned dimension, the dimension will be aligned with the dimensioning line. So that is the difference. So we can use whatever the two methods you want, but in a particular projection, you have to use only one kind. Either you can use unidirectional or aligned. Don't combine both the things in a single projection. Coming on to the principal planes of orthogonal projections. So there are three principal planes. One is a vertical plane, horizontal plane, and profile plane. So if I take this is the plane, so I'm going to observe from the front. So this is the object. So you're going to see the projection will be done parallel. You can see that these lines are parallel to the horizontal plane. When you're going to observe from the top, the projection lines are parallel with the vertical plane and perpendicular to the horizontal plane. So the front view always will be drawn on vertical plane. The top view will be always drawn on horizontal plane. So when you're going to observe from the front view, I can see what is the distance between the object and the HP. That I can specify over here. Means when you're going to see from the front view, I can see HP data that will be drawn on VP plane. When I'm going to observe from this, I can see what is the distance from here to here. So that will be drawn over here. That is VP data will be drawn on HP plane. This you have to remember. So always front view gives me the HP data that will be drawn on VP plane. Top view gives me VP data that will be drawn on HP plane. Coming to rotation, so when you go for three rotation, that is rotation of the planes. So one will be the top view and the profile view. So both will be rotated. That is top view is nothing but the horizontal plane, profile view is nothing but the profile plane. So horizontal plane will be always rotated either downwards or upwards based on the quadrant which you are projecting, and the profile view always will be rotated either left side or the right side based on the quadrant again. Always the profile plane will be beside the vertical plane and HP will be always below or above the VP. So this is the things you have to remember. Always the profile view comes beside the front view and the top view and front view will be in a straight line in a vertical manner. Coming to four quadrants. So this just I'm going to brief off. In the next video, you're going to see in depth. The point when you're going to project the point. So you're going to observe from the observer. Based on the position of the point, I'm going to define the quadrants in four different. That is, if I take the object over here, it is in front of VP and above HP. That will be the first quadrant. If it is behind behind VP and above HP, that will be the second quadrant. If it is below HP and behind VP, that will be the third quadrant. If the object is below HP and in front of VP, then the object is in the fourth quadrant. It completely depends on the observer. If I want to keep the observer here, this will be the option. If I want to keep the observer from this side, so this becomes the first, second, third and fourth. So it is purely depends on the observer position. Coming to the first and third angle of projection. So first angle projection, I am going to assume that objects are in the first angle. Third angle, I am going to assume the objects are in the third angle of projection. That is third quadrant of thing. So whenever it is in the first quadrant, when I want to take the observer from this side, the object will be resting between the observer and the screen. Means I am going to get a forward projection onto the plane. When I want to assume the objects in the third quadrant, this is the object I want to observe from here. The screen will be in between the observer and the object. So what I want to do is I want to go for the backward projection. So this is the different examples you can get, differences between the first and third angle of projection. And first angle of projection will be used by the European and Indian countries, whereas third angle will be used by United States. Coming to the last point, the drawing is the process of communicating ideas to the others in the form of understood drawings where you can understand easily. Engineering designing is systematic process by which the solution to the needs can be obtained, and the design is the act of creating the specification of a product or the process that best satisfied the design criteria. So next video, I want to see the orthogonal projection. Thank you.